Hello, dear students. Today is a lecture by Discipline, Interchangeability, Standardization, and Technical Measurements. Today is lecture number 5, theme 5. And I want to ask you, write down to your notes the theme of our lecture, System of Tolerances and Feats of Rolling Bearings. System of tolerances and feats of rolling bearings. And the plan of our lecture. 5.1 Design and types of bearings. 5.2 Bearing accuracy classes. 5.3 Scheme of placement of tolerance fields for bearing feeds on shafts and in holes in the body. Please write down to your notes our plan of our lecture and the name of theme. And we continue. We start item 5.1, design and types of bearings. Rolling bearings are most common in standard units manufactured in specialized factories. They are fully interchangeable in terms of connecting surfaces determined by the outer diameter of the outer and inner diameter of the inner rings. Complete interchangeability of the connecting surfaces allows you to quickly assemble and change worn rolling bearings while maintaining the specific quality of the units. The quality of rolling bearings is determined by accuracy of the connecting sizes, accuracy of the form and mutual arrangement of surfaces of rings and their roughness, the accuracy of the shape and size of the rolling elements and their roughness, radial and axial baiting of receivays and end face of rings. Write down to your notes these 4 items. It's the quality of rolling bearings is determined by these 4 items. And we start bearing terminology. Bearing consists from raceway, its inner ring, its outer ring. Rolling elements, balls. Cage, lubricant, and seal. Rolling elements, balls. Cage, number 4, cage. And number 5, seal. Radial bearing types. You can see the different types of bearing. First type is deep groove, angular contact. What's difference? Difference in the form of rings. You can see this form, its usual form, and you can see a form of rings in angular contact. Inner ring, outer ring. It can move in axial lengths. Self-aligning. You can see 2 rows of balls. Cylindrical roller. There are no balls. It's cylinders. Full complement cylindrical roller. Needle roller. It's needles with small diameter of rolling elements. So the difference between inner ring and outer ring is very small. And you can see that this bearing haven't inner ring, without inner ring. Only outer ring you can see in this scheme. And tapered roller. Tapered roller. Cylindrical roller element with the angle. Angle alpha. Thrust bearing types. Thrust ball bearing, single direction. Thrust ball bearing, double direction. First direction, second direction. Angular contact. Cylindrical roller. There are no balls, only cylindrical roller. Needle roller. And tapered roller. Bearing selection space. Limited radial space. Choose bearing with low cross-sectional height. Needle roller and cage assay symbols. And limited axial space. Choose bearings that can handle combined loads. Cylindrical roller, deep groove, needle roller. Please write down to your notes these two schemes. Figure 1 and figure 2. It's if limited radial space and if limited axial space. We use different types of rollers. Please write down to your notes these figures. Bearing selection loads. Magnitude. Roller bearings support heavier loads than similar-sized ball bearings. Full complement rollers bearings support heavier loads than corresponding caged bearings. Radial, some cylindrical roller and all needle rollers. Write down to your notes these figures. Bearing selection loads. Axial. Thrust ball bearing and 4-point contact ball. Angular contact thrust ball bearings. Please write down to your notes these figures. And now, before we start ISTM 5.2 bearing accuracy classes, I want to show to you some video. Let's look first video. How do ball and roller bearings works, types and durability calculation.
From Leonardo da Vinci in his studies regarding friction, but the first patent was filed only in 1794 by Philip Vaughan of Carmarthen. Then, a Parisian bicycle mechanic named Jules Serret was able to patent the first ball bearing on August 3rd, 1869. This invention allows him to win the first cycling race in history, the Paris-Rouen race. In this video, we will see how bearings work and which are the main bearing types. More than 10 years in the industry has led JAS to become the qualified partner for some of the most important mechanical engineering companies, providing any type of bearing from different manufacturers. Let's take a closer look at a classic ball bearing. By decomposing and sectioning it, its components can be analyzed. The first elements that immediately get our attention are the steel balls. They represent the rolling elements, and they are held together by a cage, which can come in different shapes, and it's made of low friction materials. Then we have the inner ring, usually the one that moves, and the outer ring, both with a groove, which can be more or less deep in order to make the rotary elements glide. It is very common for the bearing to also be shielded. The shield can be made of metal for dust protection, or it can be made of plastic, preventing liquid infiltrations. They are placed in specific locations between the two rings so that they can protect the balls and the cage from external agents. At the same time, they can retain oil or grease inside the bearing, keeping it lubricated for its entire life cycle. In order to work correctly, bearings need a certain radial and axial clearance, so that when they reach the working temperature, their thermal expansion won't lead to over-tightening, which would cause the bearings to wear, or in worst case, even a seizure.
And now the next video about bearings. You can see the same film.
Bearings are mechanisms used to reduce the friction between two objects in rotary or linear motion with each other. In this video, we will see the direction of single-row angular contact ball bearings, and in the videos of this playlist, you will see all kinds of bearings. JAS, the leader in the industrial supplies sector for more than 10 years, has become the reference partner for some of the most important engineering companies by providing them with every kind of bearing. Ball bearings are among the most widely used and well-known. As we have seen in our previous videos, radial single and double row ball bearings and the self-adjusting ball bearings support radial loads especially well. However, there are many cases in which there are also significant axial load. Therefore, the single-row angular contact ball bearings were conceived. This kind has the tracks of the bearings tilted towards the axial direction. Thus, the contact angle between the ball and the tracks is inclined. It is thanks to this shape that they can withstand combined loads simultaneously in the radial and axial direction. The more the contact angle increases, the more they can support axial loads as well. Single-row angular contact ball bearings support axial loads in one direction only, which is why they are very often used in pairs and mounted in front of each other so that together they can support greater radial load and axial loads in both directions. Thanks to these features, this kind of bearings are used in industrial pumps, electric motors, in the motor industry, and in all industrial applications where the shaft is subjected to combined loads. Do you know why double row angular contact ball bearings were invented? Find out in the next video. If you think this video was useful,
And now we are continue. Item 5.2, bearing accuracy classes. Depending on the specific indicators, bearings are divided into 6 classes: 0, 6, 5, 4, 2, and T. The list of accuracy classes is presented in order of their growth. Most often in mechanical engineering, bearings of classes 0 and 6 are used. 0 and 6, these classes are used in mechanical engineering. Bearings of classes 5, 4, 2, and T are used in machine tool building, in the manufacture of devices, etc. Measuring instruments, for example. For all classes, the upper deviation of the connecting diameters is 0. Upper deviations of the connecting diameters is 0. Thus, the diameters of the outer and inner rings are taken respectively according to the diameter of the main shaft and the main hole. Therefore, the fits of the outer ring with the housing are performed according to the shaft system. So, the fit of the outer ring with housing are performed according to the shaft system. And the fits of the inner ring with the shaft are performed according to the hole system. Tolerances and resultant fits chart. For normal operation of the bearing, it is necessary that there is a clearance between the rings and the rolling elements. It is possible to ensure the operating clearance within the required limits only if the fit is correctly assigned and the fit clearance of a given size is maintained, which will depend on the operating conditions of the bearing. In this scheme, you can see the minimum clearance in the housing and maximum clearance in the housing, in the connection of outer rings of bearings with housing, with the hole in the housing. And minimum interference on the shaft and maximum interference on the shaft. In the feet with inner ring with the shaft, with the outer surface of the shaft. Green, you can see tolerance field, green color. Tolerance intervals of the bearing bore and outside diameter. Tolerance interval of the housing set. It's yellow color. Green color again. It's tolerance field of the bearing, of the ring of the bearing, and tolerance interval of the shaft set. Of course, zero line, it's nominal diameter of the inner ring and outer diameter of the outer ring is zero line. It will be plus above the line and under the line, and under the line we will have the minus. Plus minus zero line. The choice of fits in the connections. The choice of fits in the connections of the inner ring with the shaft and the outer ring of the bearing with the hole in the housing is carried out depending on the type of loading of the rings. There are three main types of ring loading. Write down to your notes three main types of ring loading. Circulating, local, and oscillatory. With a circulating load, the ring perceives the radial force consistently around the entire circle, which takes place with the relative mobility of the ring and the radial force. With the local load, the ring perceives the radial force by a limited section of the circle, which occurs when the ring and the radial force are relatively immobile. With an oscillatory load, a force constant in direction is combined with a smaller rotating radial force, while the resultant force does not complete a full turn, but oscillates in a certain section of the fixed ring. This type of load is, as it were, intermediate between circulation and local. Please write down to your notes 3 types of ring loading and about these types. What about circulating load, local load, and oscillatory load? Write down to your notes these types of load. Selection of feet. The heavier the load, particularly if it is a shock load, the greater the interference fit. Elements will head up differently, causing expansion. Tolerances on shaft and housing. You can see clearance before mounting and clearance after mounting. And its interference fit between inner ring and the shaft. And you can see on the figure 2 the way of expansion of worm in the connection of shaft with inner ring. And now we start item 5.3, scheme of placement of tolerance fields for bearing fits on shafts and in holes in the body. The following basic deviations of shafts and holes in the body are provided for bearing feet. With circulating load for shafts, J suffix S, K, M, N for holes, K, M, N, G. At local load for shafts, F, G, H, J, S, J, S. For shaft, only small letters we use. And for holes, big J suffix S, H, and G. The location of the tolerance fields of shafts and holes relative to the zero line is shown in figure. At the same time, the bearing fits differ from similar standard general purpose fits in the values of limit interference and clearances. In matin bearings with parts of mechanisms, more accurate fits are obtained than in matin parts machined according to the same IT grades. Since the certain surfaces of bearings are machined according to IT2, IT5, and parts according to IT3, IT11. Scheme of placement of tolerance fields for bearing fits on shafts and in holes in the body. Please write down this scheme. You can see the tolerance field of the hole in the housing. And the difference tolerance fields of the outer ring of the bearing this is the tolerance field of the outer ring of the bearing. And the difference tolerance field of the housing of the holes of the housing from F to P. It can be IT grade 7 or 6 or 8. We can see clearance fit if the tolerance field of the hole in the housing will be F, it's a fundamental deviation, F, G, or H. H6, H7, H8. You can see difference between these tolerance fields. If IT grade is higher, the higher the tolerance field. Transition fits with outer rings of bearing. If we have a tolerance field of the hole in the housing, J 607, K 607, and M 607. IT grade 6 or IT grade 7. J, K, M. It's transition fits. And interference fits we will have if the tolerance field of the hole in the housing will be equal N6, N7, P6 or P7. IT grade 6 or 7, and fundamental deviation of tolerance field, it's N or P. You will have interference fits in the connection of outer ring of bearing and inner the hole of housing. For the inner ring of bearing, zero line, tolerance field of the inner bearing. Always under the line, under the zero line. It's zero line too. And we will have transition fits if tolerance field of the shaft will be J5, J6, H5, H6, J5, G5, G6, H5, H6, J5, J6. For interference fit, the tolerance field of the shaft will be equal K5, K6, M5, M6, N5, N6, P6, R6, R7. IT grades can be or 5, or 6, or 7. And the fundamental deviations K, M, N, R, it's for interference fits, it's fundamental deviations of the shaft, outer surface of the shaft. And for the transition fits, G5, G6, H5, H6, and J5, J6. Please write down to your notes this scheme of placement of tolerance fields for bearing fits on shaft and in holes in the body, in the housing. Nominal diameter of the outer ring and nominal diameter of the inner ring. Write down to your notes this scheme. Write down to your notes this scheme. It's very important scheme with the locations of the tolerance fields of the hole and of the shaft in the connection with rings of bearings. And we are continue. With a circulating load, feeds are selected according to the value of P suffix R, the intensity of the radial load on the landing surface. It's calculated by the formula on your screen. In this formula, F suffix R is the radial reaction of the support on the bearing. B, working width of the set. It can be big B. B, working width of the set. K suffix 1. K suffix 2 and K suffix 3. Okay. It will be K suffix 3. K suffix 3, K suffix 1, K suffix 2, and K suffix 3. K suffix 1, dynamic coefficient, Depending on the nature of the load and overload, it will be from 1 to 1.8, case suffix 1. Case suffix 2 is a coefficient that takes into account the degree of loosening of the feed due to the compliance of the hollow shaft or thin-walled housing. Depends on the ratio of the diameters of the shaft or housing for solid shafts. So K2 is equal 1. Case suffix 3 is a coefficient of uneven radial distribution in double row tapered roller bearings or between double ball bearings in the presence of an axial load on the support. Big B is the width of the bearing. Small r is the radius of curvature of the width of the chamfer of the bearing rings. So you can see that big B minus 2r, it will be equal small b. And small b it's working width of the set. Difference between small b and big B, that the small b is working width of the set and big B is the width of the bearing. The roughness of the setting surfaces of the shaft and the holes in the body associated with the rolling bearings should not differ significantly from the roughness of the surfaces of the bearings themselves. For bearings of accuracy classes 0 and 6 with a diameter of matting surface up to 80 millimeters, R suffix A is less than 1.25 micrometers. Permissible deviations from the correct geometric shape of the setting surfaces of shafts and housing cannot exceed half of the processing tolerance. Write down to your note this parameter of roughness for surfaces of the rings of the bearings. Designation of bearing feeds in the drawings. The roughness of the setting surfaces of the shafts and the holes in the body associated with the rolling bearings should not differ significantly from the roughness of the surfaces of the bearings themselves. For bearings of accuracy classes 0 and 6 with a diameter of mating surface up to 80 millimeters, R suffix A is less than 1.25 micrometers. Permissible deviations from the correct geometric shape of the setting surfaces of the shafts and housing cannot exceed half of the processing tolerance. Please write down to your notes the scheme with designation of bearings fits in the drawings. You can see two types, first variant and second variant of designations of bearing fins in the drawings. With accuracy class of bearings and without accuracy class of bearings, only tolerance field of the shaft in the connection inner ring with the shaft, and for the connections of outer ring of the bearing with the housing, with the hole in the housing. You can see two variants of designations, two, and in first value you can see accuracy class of the bearing. In the second variant, without accuracy class of the bearing, only tolerance field of the hole, for example, H6, H is fundamental deviation of the hole of the housing, and 6 it's IT grade of the hole in the housing. Please write down to your notes this scheme with two variants of designation of bearing fits in the drawings. And one more time, please write down to your notes this scheme with designation of bearing fits in the drawings. You still have 5 minutes. And now we have finished our lesson. It was last slide. So, for now, we finished our lesson. See you next time on the next week. Goodbye. Be safe. Have a nice day. See you later.